Hi, folks. This week we are going to talk about electricity and just the basics of electricity. And this primarily is going to be about conductors and insulators. But let's begin by talking a little bit about what we mean by electricity. Electricity is a form of energy, and I know you know what electricity is because you turn on lights and you use a refrigerator and a cell phone all the time. But it is a form of energy, and it's due to the accumulation and the movement of charged particles. Due to the law of conservation of energy, this movement of charged particles is a fabulous thing because we can take that energy and we can transform it into other forms of energy. Heat in an electric stove, light through light bulbs, motion in fans, and magnetism in some sort of an electromagnet. So electricity is just such a versatile way of moving energy from place to place. There are two primary types of electricity, and in the lectures we'll talk about that. One form is called static electricity. Static as in stagnant or not moving. Remember, static friction. Friction is between objects that are not yet moving. And this is that accumulation of charge when you rub your feet on the carpeting and your hair sticks up all over the place. That's static electricity. Once the charge actually jumps, once that spark jumps, it becomes current electricity, and those are particles in motion, and we will refer to and talk about both. But before we talk about those, we have to talk about the difference between conductors and insulators. Some materials hold on to these electrical charges very, very well, and some materials allow those charges to flow easily. And those are those big categories of conductors and insulators. So what's a conductor? A conductor is some sort of a material that will allow that electricity to pass very, very easily. They tend to be metallic, water solutions, so salt water, things like that, and graphite, which is one of the pure forms of carbon, are all excellent electrical conductors. This chart of relative conductivities of metals gives you an idea of which metallic materials are good electrical conductors. Silver is the best electrical conductor, followed by copper, gold, and aluminum, and you can see some other metals listed there. Now, if silver is the best electrical conductor, why don't we use that to wire our homes? Well, two reasons. One, silver is a lot more expensive than copper. Copper is pretty pricey, but silver is even more pricey. The other challenge is silver has a really low melting point, so that would be very dangerous in our house. Gold, also a good conductor, but not as good as copper. So gold would be a great conductor. The challenge with gold, or the, advantage where gold is used in some circuitry, is it does not corrode. It doesn't oxidize. And so gold is used in some circuitry. Old-fashioned homes, some were actually wired with aluminum because aluminum was considered the hot metal about 50, 60 years ago. The challenge with aluminum is that it also melts relatively easily, and that caused some potential fire hazards. So all of these things are good electrical conductors. One of the things I think is fascinating to note is that things that are good conductors of electricity also tend to be good conductors of heat. That has to do with the fact that how the electrons are arranged within the material. We'll talk more about that later. Insulators are substances that do not transmit electricity very easily. What are these things? Well, rubber, glass, dry wood, and non-metallic stuff. A lot of hydrocarbons, plastics, rubbers, things like that. If somebody is going to work in a electrical environment and the workers need to be protected so that they do not short out or potentially get electrocuted, two things that might occur. One, they might be asked to stand on a rubber mat and wear rubber-soled shoes. That's a way to protect them from being grounded so that they do not absorb shocks through their feet. Power lines, the insulators are very often made of the old-fashioned glass ones, are collectibles because they're beautiful and made lots of cool colors. The modern ones, ceramic, porcelain was popular many years ago, but those are all non-metallic things. Something as simple as a screwdriver is made with intention. The fact that that handle is made out of a rubber or a plastic is so that if you stick the metallic end of your screwdriver in someplace stupid and you pick up an electrical shock, the shock will not be transmitted to your hand. So that is on purpose made to be an electrical insulator. You might say, Mary, why is there a picture of a cow here for insulators? Well, this is a rubberized cow mat. 20, 30 years ago, it was a big deal in farming and dairy industry to talk about stray voltage. And a lot of people were noticing that there were low levels of electric current running through the ground, the concrete of cow barns. And it was having an adverse effect on the dairy herds, and milk production was going down. The rubber mats have been put into a lot of cow barns. It's a lot more comfortable for the cows. They're not picking up tiny bits of stray voltage that are running through this concrete that is, of course, being saturated with water and urine from the cows. So it's an excellent conductor of electricity. So it protects the cows. It's more comfortable, and it protects them from the stray voltage. Why? Because it is an insulator. Let's talk about water and electricity. Not all liquid solutions conduct electricity. We've all been warned by people who love us and care about us that you do not work with your electrical appliances near your bathtub. That is bad, really, really bad idea. Why? Because you could die, and we don't want that to happen. So if that's true, and it is definitely true, why can I say that distilled water does not conduct electricity? Well, let's talk about this a little bit. Only solutions that contain ions conduct electricity. So what do I mean by an ion? Ion is a charged particle, something that is positively or negatively charged. Tap water, the water that you and I drink, is H2O, but it's not pure water, not unless you are running around drinking distilled or deionized water. That water also contains trace amounts of minerals, maybe some calcium ions, maybe some sodium ions, maybe some chlorine ions. And those ions inside the water conduct electricity. It's not a lot, it's a very small amount, but it's enough to make the water that you bathe in a really excellent electrical conductor. And that's why that is a very bad idea to drop an appliance into a bathtub. You could die. And that's why we have ground fault interrupters next to our sink, or any place that water and electricity are near each other. I'm going to encourage you to watch the short little 2-minute video from the folks at MIT where they show you a demonstration of which liquids conduct and do not conduct. And they'll demonstrate that things like oils, alcohol, sugar in distilled water, things that are non-ionic do not conduct electricity, but things with ions do. Before we leave this page, I want you to take a look at this picture I found online. This very kind woman was trying to produce bubbles for her child in the bathtub. But if you look at this picture closely, this is a little hand mixer, and the hand mixer has a cord, and you can see the cord behind her. Eek. Don't do that. Do not do that at home, especially if you want to keep your family safe. All right, that will do for this time, and we'll see you later. Bye-bye.